In this final module, we'll be looking to the future to see what some of the upcoming exoplanet surveys will be and how amateur astronomers can contribute to the professional astronomy community. If we take a look at the current exoplanet observations that have taken place, they're actually relatively small number and relatively close to our own solar system. For example, in this diagram, you see that ground-based observations are really only around a certain perimeter of our own solar system. Some of the exoplanet observations by Kepler, which are most of them at this point, are just in a small cone in the arm of our galaxy, extending out as you see it. And there's been some micro-lensing exoplanet observations toward the center of the Milky Way, one being the one you see here. But for the most part, the relative number of exoplanet observations are relatively small. Now, what's going to be soon happening is the launch of the TESS satellite, which will do an all-sky survey of exoplanets, as opposed to Kepler, which, as you just saw, really only covers a small cone in one of the arms of the Milky Way. There will also be future surveys done by such space telescopes as James Webb telescope, which will mostly be in the infrared, and WFIRST. WFIRST is important because there's a potential that it might be able to detect some of the elements of the atmospheres of exoplanets. Now, if we turn to the more immediate space telescope survey that will be taking place, TESS. TESS is going to be, as we said, an all-sky survey, and it's going to be taking place, it's going to be launched probably in early 2018 of the current plans, but it will require a lot of amateur follow-up because it will identify a patch of sky, for example, where there are potential exoplanet transits taking place. This will be based upon brightness of areas seen, but not necessarily refined as to which stars are actually performing or conducting an exoplanet transit. And in addition, there needs to be a discernment as to whether these change in light are due to, for example, an eclipsing binary or indeed a true exoplanet. So with the launch of TESS, there will be a large demand for amateur astronomer follow-up to actually confirm candidates as being exoplanets. An interesting concept that NASA is looking at is so-called starshade technology, whereby a space telescope will be launched with a starshade many thousands of miles in front of the telescope, and the starshade will act like a coronagraph in space, where it will block out the central brightness of the host star so that the telescope, space-based telescope, can pick out in the surrounding area of the star an exoplanet. That is to say, to actually be able to image an exoplanet. This particular technology, if it's successful, is several years away, but it's worth mentioning as one of the ways that NASA is looking at doing direct imaging. So to summarize, I think it's fair to say that amateur astronomers are able to conduct exoplanet transits with amazing accuracy. We've already seen that how amateur astronomers can contribute to exoplanet research and to work hand in hand with professional astronomers. And with the launch of some of the large surveys such as TESS, the need for observations by amateur astronomers is only going to grow in the future. We've already mentioned some resources that are available online. I think it would be worth mentioning a few others that would be helpful in your exoplanet observing. One is a practical guide to exoplanet observing. This can be found on astrodentist.com, and it provides a summary of best practices, some of which we've covered already in this course, as well as a much more detailed step-by-step guide to using AstroImage. Bruce Gary had published one of the first books on amateur observing of exoplanets that you also might find very helpful. Michael Perryman has a handbook on exoplanets that is much more technical, that provides even some of the mathematical background on the various types of exoplanet observations, not just the transit method. A book by Richard Berry and James Burnell is excellent as a background book on image processing in general, but also in particular some of the fundamental concepts that are important to understand with respect to photometry. And finally, there's some very good guides and manuals by the AEVSO, in particular, one on CCD photometry and CCD observing. Both of these manuals are useful in helping to understand some of the basics of high precision photometry. So that concludes our course, and we wish you all the best with your exoplanet observing and clear skies.